this up.
So, as I said, I don't think any of this is current relevant stuff. All kind of older stuff. But yeah, before we look at the scoring and stuff, if you need to borrow a different colored pencil, please come get it. And the top of the page does have that same bit.ly link if you prefer to look at the scoring on your own. But this is the right one, correct? Number 4, is that the one you did? Okay. All right, so it looks like part A had 2 points. You had to come up with what the answer was, which would be 0.2. And you had to have work that showed where 0.2 came from. So great if you could do that in your head, but if you didn't show where 0.2 came from, then you're not going to get that point. It says with supporting work. Now, again, anything equivalent to that is fine. If you left your answer 2/10, 1/5, anything that's the same as 0.2 gets you the first one, as long as you have the reason that goes with that. And again, like we normally do on these, you know, half of you probably need to ask about part A, and then a different half may need to ask about part B, and a different half needs to ask about part C. But I don't want to give up half of class on these, so that's why I include those links to the videos. So either as part of your homework, or eventually when you start reviewing for the AP on your own outside of class, at least you have a video you can go straight to and look it up. Okay, it looks like the second point came from if you put units. So centimeters per day, which is the same thing as, you're probably more likely to write it like that. It's like feet per hour squared type of thing, yeah.
If I got the first part wrong, but I got the units right, would that count as a point?
Yep. Even if you got the first part wrong, the way this one was scored, if you got the units correct, you still got a point. Now, I will say this, they tend to do a pretty good job of, they will specifically ask you for units if they're going to grade you on units. So if you finished early and then you didn't put units to part A because you didn't know you were supposed to put units for part A, that's exactly what you should do with your extra time. Reread the questions and make sure that there wasn't something else they wanted you to do. All right, for B, looks like it's another 2 points. Looks like you needed to show, I don't really remember this one. I guess I should find mine. But I'll do that in a second. You needed to show that -6 was bigger than r prime at 0, but less than r prime at 3. Again, I don't really remember what that means because it's been a while since I've worked this one. But and then a second point saying that there is a time where the rate would be -6. And unfortunately, this one's pretty tough, but you had to refer to intermediate value theorem. So the fact that this was -6.1 and this was -5, intermediate value theorem was the one that made sure, or said that you would hit all of the y values in between. So if it's hitting -6.1 and -5, it's going to hit everything in between, like -6. So you could abbreviate that as IVT, but they're not usually quite that picky with IVT, but this one they were. Yeah.
So you have to like say IVT, you can't just write -6.1 is less than 6. So.
Well, okay, so if you say that, that's a true statement, but then what does that have to do with this question?
Like, do you have to clarify that?
You have to clarify somehow that, you know, just because the slope was -6.1 and then the slope was -5, how did you know it had to be -6 somewhere in between? So you could either A, explain the intermediate value theorem, or just say that I know it's true because of IVT. So, short of you explaining it on your own without referring to IBT, that's the easiest for sure. All right, so that one's probably pretty low as far as getting that point, but. All right, part C, this one should have been a little bit easier. A right Riemann sum with 4 subintervals. So the table had 4 little sections, so it's a little easier to get there. I guess if you didn't read the question carefully, you needed a right Riemann sum. So you could do 1 point, if you showed where your work was coming from, and then 1 point for the answer. So again, the answer could be -51, or you could have stopped right here. As long as you have that exactly right. Remember, you don't have to do any arithmetic. There's no benefit in you trying to do all of this arithmetic without a calculator and hoping you get -51. You're just rolling the dice and maybe losing that point. You don't have to simplify any arithmetic. Now, they don't consider this arithmetic though, just to be clear. This, you actually had to plug in what it was. R prime at 7, you actually had to plug in what that was. This is not considered arithmetic, yeah.
What if I just plugged in like the values instead of specifically writing R prime 3 and R prime 7?
Like this.
Okay, yeah.
Yeah, it sounds like they would give you both points if you just wrote that stuff,
Okay.
unless you had an error in it. Okay, so that went, how many points has that been? 6?
Wait, so you get a point for writing it like that?
Like what?
In that format?
Yes. They will take, based on this scoring, they would, what they were hoping you would do, is show this for a point, but in the scoring notes, if you just did this, they also gave you the first point. Unless there's something wrong. Like if you plug the wrong number in there or something, then you would lose the point. Okay, and then finally to the last part. I do remember the last part was a related rates, which again, this is why we need to get on to reviewing so that we can actually talk about these things a little bit more in depth. But you should have taken the derivative of that with respect to time. So there was 2 variables. So you get 1 point if you did the product rule. A second point if you did the chain rule. So if you had something like this, you showed that you did the product rule, and within that you have the chain rule as well. Now of course, here you could just have R prime, H prime, V prime. You don't have to write it with that notation. But to take that derivative, you had to do product rule because it was R squared times H. And you had to do chain rule, these two, because you took the derivative of V with respect to a different variable, the derivative of R with respect to a different variable, and the derivative of H with respect to a different variable. If you forgot any one of those, you don't get the chain rule point. Okay, and then I think the last point, is this the 9th point? This is the last one? Okay, would be the answer. So again, you could either have this, or you could have anything that's equivalent through arithmetic, which could be that. From here to here is just arithmetic. You guys need to start trying to stop as soon as you get to this. You're just running the risk of making a silly mistake and then missing this point. Now, if you didn't set this up correctly, you don't get the point. If you didn't come up with this answer, or if you didn't come up with this, you don't get this answer. But if you do this part correctly and then you have this part wrong, you don't get the point. You don't get 2 swipes at it. So You could either have this in blue, or you could have this highlighted, or anything equivalent to that, and you could get that point. Okay, so I don't think, did I have the average score written on the top of that one? The top right? Is that a no? Okay, I had to look it up. It looked like the average was 2.97. So if you want to write that on the top of your FRQ, 2.97 was the average. Now, I would suspect that you guys probably felt a little bit worse about that one. But again, remember, the average is coming from students that took the AP exam after they did the AP review and all that kind of stuff. You guys have not thought about related rates in months. Well, I don't know. You should have reviewed it for the final exam, the fall final exam, I guess. But if nothing else, this kind of tells you a couple things that you can be a little more careful on, and maybe a topic or two that you need to look at before the AP exam. As always, I'm not trying to get you all to study your life away to try to get 9s on all of them, but now that you've seen this, you should be able to identify 1, 2, or 3 points that you feel like you could have gotten if you had been more careful, if you had read the directions better, if you study related rates for a couple minutes, something, so that next time you can do just a touch better. That's all that I'm asking. All right, so now let's actually move on to what is current. So the handout you picked up, the notes one is 113. So this is where I'm going to remind you what we did with, yes, washer method and this method with the first 4 questions. And I'm going to tell you one thing about those where you can do them around other lines. And then all of this comes up in the circuit that I want you to practice. So I know you guys did two Khan Academies for me last class, but that's not enough practice for these to feel confident. So that's where the circuit's going to come into play. Okay, so when we talked about this on Monday, I hope that I came across that having a sketch is going to help you out quite a bit. So y equals 3, x equals 5, y-axis, x-axis. That should trap in some area. That area is what we're going to spin 3-dimensionally to create a 3-dimensional shape that therefore then has volume. So the parts that I tried to emphasize last class is if you're rotating it around the x-axis, you should be integrating dx, and the limits of integration should come from x values, so 0 to 5. When we take one of these outer points and rotate it, we can see some of the cross sections that would be created if we spun this 3-dimensionally. But the point is, all of the cross sections are circles. Always, always, always circles for us. So that's going to be pi r squared, area of a circle. And then the part that you had to definitely slow down on and be as cautious as possible is what r is. Because r is not always just a number, and it's the easiest part to miss. But for this one, this length is 3, this length is 3, this length is 3. It looks like the radius of all of these would be 3. Now, since these numbers are so easy, I'll just go ahead and integrate. So that would have a volume of 45 pi. Now, to be fair, that's a pretty lame example because that really would just be a cylinder. You could really just use a geometry formula there, but let's get the same answer. Okay, and then question 2, if we did the same thing, but this time around the y-axis, so without even putting any thought into it, I know it's going to be dy. I know this stuff needs to be in terms of y, and the limits of integration needs to be y values. So, unless a picture is already drawn for you, that's probably in your interest to sketch those. That's going to help you see the area you're going to rotate. Now, I think this is the same graph as number 1, but this time we're rotating it around the y-axis. So instead of 0 to 5, it's going to be 0 to 3. It's still going to be an infinite amount of circles, so pi r squared. But now when I take one of these outer points and rotate it around the y-axis a couple times, I can see that the radius is 5, the radius is 5, the radius is 5. Without drawing in a couple of those cross sections though, it's a little bit harder to see that the radius of each of them would be 5. So this would integrate to 25y. Plug in 3 to get 75, plug in 0 to get 0. 75 minus 0 would be 75 times pi. Same thing. I'm just making an easy graph as a reminder so that we can just talk about the big picture stuff. But that's really just a cylinder. You don't really need calculus for that. But that's the 2 examples I'm giving you for the disk method, revolving around the x-axis or revolving around the y-axis. So, is there anything you want to clear up about 1 or 2 before I talk about the washer method? Okay. Then question 3 and 4 are going to be 2 quick reminders about the washer method, one around the x-axis, one around the y-axis. So your approach should basically be the same. Now I guess one thing to note is that the questions are never going to say, hey, find this volume using the disk method, or hey, find this volume using the washer method. You have to be able to differentiate whether it's going to be disk or washer. So the quick way to do that is if I'm rotating this guy around the x-axis, what you need to notice is the area right next to the x-axis is missing. So when I rotate this, the missing area becomes a missing volume. And when part of the volume's missing in the middle, that's when it's the washer method. So we're going to do pi big R squared minus little r squared, where big R squared is going to be taking the outside points and rotating them over the x-axis. Again, a couple quick ones will help you see that the radius of each of those is going to be 3. But that's what we would stop at if there was no missing piece in the middle. So we have to go back and subtract how much was missing. So this missing area here, when we rotate this, becomes a missing volume. Again, drawing a couple cross sections. I'm just taking a point on the enclosed area and rotating it around the x-axis. Those all look to have a radius of 1. So this would be 3x. Since it was around the x-axis, we should be using x values. And I'm getting 15 pi. So again, it's like doing the washer method twice. The big overall volume, subtract the inner volume that's missing. Yes, Grace?
Would it be
2?
rather than 3? The radius is only from 1 to 3.
this radius is the 3, right? This radius was the 1. I mean, I do see I have one mistake here, but I don't know what you said was right. 3 squared should be 9, minus 1 squared would give 8. Sorry, so my arithmetic was wrong there, but
Oh, okay.
okay. And again, try to structure it this way: big R squared minus little r squared. And if you understand that one, then there's not much different with 4, but just to give a quick reteach of all of them. We'll now rotate it around the y-axis. Bless you. Okay, so even without a picture, I know it's going to be dy. Now that I have a picture, or algebraically, if you're careful, you can see it's 0 to 3, smallest y to biggest y. If I take one of the outside points and rotate it around the y-axis, it helps me see the big R. It looks to be 5. If I take a point on the inside of the enclosed area and rotate it around the y-axis, it helps me see little r, which appears to have a radius of 2 always. So I'll be more careful here. I have a mistake, but this mistake I did on purpose, so I want to see if you'll catch it at the end. This would be 25 minus 4, which would be 21. Integrate that from 0 to 3. So why is 63 not the answer? Good. It's a bunch of circles. Pi r squared. You got to have the pi in there. Again, typically multiple choice, you guys don't forget that because all the choices have it usually, but free response, that's probably the most missed thing, is just forgetting the pi. Okay, so now we're going to take one step further, although it's, again, basically the same idea. So, looking at question 5, I'm not even going to tell you what's different yet, but we've got a region R that's trapped in between this stuff. Now, what makes this question different is I'm not rotating it around the x-axis, nor am I rotating it around the y-axis. We are actually going to rotate this around y equals -1. So you should probably graph that like as a dashed line. And maybe even better to do the little like circle arrow thing so that you remember which part of this graph. Okay, so this certainly makes a difference what I integrate from and to, and whether I do dx or dy. So if you had to guess whether it's dx or dy, what do you think it would be? Okay, why are you guessing dx? You're correct, but
It's horizontal line.
that's exactly it. So it's not that it's dx when you rotate around the x-axis, it's dx if you rotate around a horizontal line like the x-axis, or like the line y equals -1. 0 to 6. So again, dx if you rotate around a horizontal line like the x-axis, and it will be dy if you rotate it around a vertical line like the y-axis. Just that those are just very specific cases. Now, the rest of this is basically going to be the same. It's going to be pi r squared, because of infinite number of circles. I've got area missing next to the line I'm rotating it on, so I know that missing area is going to create missing volume, which makes this a washer question. And then the rest is just being careful. Be careful not to rotate it here, rotate it here. Take a point on the outside of the trapped area, rotate it around this line, and it looks like that radius is always going to be what? You said 2? Yeah, 2. Because we're not going to the x-axis, we're going down to y equals -1. It makes that radius 1 bigger. The smaller radius, the missing volume, is only going to have a radius of 1. Now again, obviously those can be algebraic functions instead of just numbers, but that's a problem for another time. So 4 minus 1 would be 3. Integrating 3 dx would be 3x. So it looks like 18 pi in the end. It's plugging in 0. Since plugging in 0 goes to 0, I can do that pretty quick in my head if I'm not making a silly mistake. So once again, the only new thing I'm saying there is I did dx. The limits of integration were x values because I rotated it around a horizontal line like the x-axis. It doesn't exactly have to be the x-axis. Okay, so you could probably guess on this one, but for completion, let's go ahead and finish filling this out. Bless you. All right, same area, I believe. But this time we're going to rotate it around x equals 7. So graph x equals 7 as a dashed line. Even better if you do the little circle with an arrow. It's just a little more of a visual indicator what you're trying to rotate it around. And since I'm rotating it around a vertical line like the y-axis, that's how I know it's going to be dy and y values. That's the only difference between that and what we did on Monday. Infinite number of circles. Missing area right next to the thing I'm rotating around, which is going to create the missing volume. That's how I know it's washer instead of disk. Take a point on the outside of your enclosed area, rotate it around. Looks like that radius length would be what?
7.
Very good, 7. 0 to 5 here, plus 2 more to get to the line we're rotating it around. And then the inside area rotated around that line is going to show you the missing volume when you rotate that shape, and those all have a radius of 2. Okay, I'm going to put in one more mistake here that I'd like you to try to look for. Let's see, this would be 49 minus 4, which would be 45. Integrate that, that would be 45x. So, okay, what mistake did I gloss over? Yeah.
It's terms of y, so it should be y instead of x.
Right. If you're integrating dy, it doesn't become 45x, it should become 45y. Now, that doesn't change what the answer is, but it does change whether the integration is correct. And that would matter on a free response, because one of the points might just be to see if you integrated it correctly, and x is different than y. So, okay, so on the circuit, they're not all going to be questions like this around other lines, but it should start off with just some regular old disk method questions before it gets into some washer methods, before it gets into lines other than the x or y axis. But this will be the bulk of practice that I can give you for this topic. So go ahead and start chipping away at the first few. And I'll give you a little bit of a head start, and I'll finish putting in these homeworks. and then I'll come around and help. And of course, if there's a common problem holding everybody back, then I'll address it on the board. But in the end, there's only 18 questions here. I will go ahead and ask also that if the integration is pretty easy, like the notes that I just went over, go ahead and integrate by hand. But if the integration's kind of nasty looking, feel free to just throw it in your calculator. Again, you obviously need to know how to integrate, but my focus is on you setting these up correctly and understanding this question type. We can always practice integration another day.
I think we did the first one right. We can't find the right answer.
What did you get for an answer?
84.5.
I got 96 pi.
6 times 6 is 36, not 24. Sorry. I did it in like 2 seconds. Sorry.
Oh, square.
like 6 times 16.
That doesn't sound right.
You did right.
Okay, area of the circle is well. Yeah, same thing someone else did. Like I said, that's why I just keep emphasizing that, because you get so focused on the calculus that you forget part of the circle thing.
What did that be? Bonus information model.
Well, I don't, but I was all guys have stretch marks.
Oh, yeah, thanks.
We'll just think about squared over 2.
Why do you guys are so different? I've never heard bad things. Just what you guys talking
No, to this good.
That's what you guys said.
The way I did it.
I think that's an Asian thing. But also, like, being social comes up in like, like, you have to get exposed.
It's once you run the x-axis.
Yeah, that's what
Oh,
I was doing that a lot.
I'm sure when I
It's just, yeah.
it's just divided by 2.
But you don't understand. Because it's supposed to run the x-axis. You don't have to like middle section. You just, you have to
It's like in the middle of anywhere.
Okay, maybe wait, gosh, that's the first
Yeah, you're really gross. I'm telling you.
So how?
Well, how would you integrate? I think they look like that. So they're softer.
Okay, so
No, really. You're like crawling on
no, the boundary.
I've got 6 different answers. I've got 13.5. I've got 45 over 2. It doesn't seem okay to me, so.
It's just how people say it, like,
That's why it's not
Mag was squared is 9.
It's just funnier when. I just don't want you to think I'm. Okay, well, so.
What's it called? What are these extra papers?
X squared.
I'm proud. I'm not proud of you.
Oh, you missed. So, okay. So yeah, you got that. The radius is like this.
I didn't get it already.
Yeah.
So you do like.
Seems like the radius is just one
and you
line.
have
It's
practice.
just one line. There's different values, and all you do is one line.
Is there no line? Oh, well, it says bounded by y.
I think so, somewhere.
So you would just.
It's right over there.
Oh, yeah, first page.
Just plug in. So once we're.
Why should we do that? I think the solar one should tell me.
Use them where I went wrong with this. Feeling.
Okay, so
Must
where's
be a
your,
wash.
where are you, or what area are you rotating? I don't see your area. Shaded in a little bit, so I know that you're looking at, okay, that's good.
That's helpful.
Okay, we're on the y-axis, so 72.
Wait, I wanna see.
Okay, the problem is this isn't 0 to 2.
Okay.
You're thinking x values.
Oh,
It should be 0 to 4.
Yeah, I wanna switch.
you done with
Something like that? What? Y-axis. Okay, so we're gonna y-axis.
What number?
Are you sure the most common thing is on everybody's been doing pi r squared? Squared. Around the x-axis. Okay. What did you say the bounds were?
0 to 6.
1 to 6.
1 to 6.
Oh, okay, they're feeling it.
I just want that.
Did you graph it or did you not?
I need a different palette.
Just whole thing parentheses and square. R squared.
Probably gonna show you what you can. Wait, is Kristen not on that list?
What are you on?
So do you have to do anything to this equation to get that over, or do you just leave that on square root of y?
I was about to tell you, Katie.
No, you do this y. Okay.
So your inner radius would be this, from the y-axis to this, which changes the distance from here to the right is what I would call x. But x doesn't equal y, so you can't just replace x with y.
Y square root of y.
Oh, okay, then you
Because
square,
square root.
okay, I'm sorry, I didn't get that.
Yeah,
0 to 3.
so that's gonna be right.
Oh.
Also, I have that as number 15, but now you're not number 8, so you have a mistake somewhere else. You can worry about that later.
Yeah.
Is it four?
This is the same thing. True. Okay.
No, I have that as number 18, but.
Oh, yeah, that's the one.
Okay, but we can still talk about
I'll just
this.
subtract 32.
So I'm with you so far.
And then if you're rotating it around x equals -2, then you need to take some of the area from the outside and rotate that. So this would be the, or it's the big radius. Okay, and then minus,
There's a lot of information.
because there's some area that's not there. The smaller radius would be
Do 6 times 6.
here to here.
These plugins.
Well, but here,
You have to like.
from here to here, the small radius would be 2. So right here, the radius would be 2 plus this line. Because it's really trying to get to this line. See what I'm saying? So down here at the very bottom, when y is 0, this small radius is 2. But if you go up a little bit, now it's 2 plus this little extra. It's trying to get to this line. This is 2 plus this extra. All of this is unshaded, so all of that would be part of the small one.
Let me draw the picture.
That's not it.
Yeah, I don't know.
Oh, well, I wrote this on over, so.
Okay, so that's your area. And you're trying to rotate it around x equals -2. Okay, so.
What?
So vertical line, dy, 0 to 4. I think we're all agreeing on that part. Okay, so for the big arc, you should be taking the points on the
Yeah, this is
area
my number 6.
furthest away from this as possible.
I messed something
So
up.
this, we rotate, will be about that size. And we're all okay that this radius would be 2 plus this, which is 2 more.
Yeah, they can see this.
So it's 4? For the small radius though,
I think that's 2.
Let's just draw this. Minus.
Forgot the square.
small radius is gonna change.
Well, I got 56.
Right here, the small radius
Maybe I
is,
cut it lines.
but right here,
I don't see 56.
it's,
That's
this
what I got.
area is missing, so that's gonna create more.
Which is just x squared.
How in the world?
Well, it can't be x squared because this is dy. You need this to be.
Oh,
Square the whole y,
Yeah.
plug in 0, you get square
Okay.
root of 0.
Wait, so you think it's y?
because square root of y squared times the square root of y.
Okay, what do you think the radius is
Root of y.
for this
That
one?
would be worse.
Don't square, just what is the small radius? Okay, so let's test that. When y is 0, what would you
I
say
just
the radius
simplified it
is?
before.
Okay, when y is 0, is the radius 0?
Guess what the answer is?
The radius is 2 plus wherever that is.
Two plus
2 plus that distance. Always is 2, this part's consistent, and then this part is
oh,
y. Or, I'm sorry, x squared, which is square root of y.
they used to have like a cube.
But that's also a tougher question that you should be building up to. That's not, you're not supposed to get to this one until number 18, so. You can try to finish it if you want to, but again, it's better if you build up to that. Yeah, that inner radius is very tricky. It's not just the square root of y. You can plug in y values and see that it's always too short of what you want it to be. So you have to add 2 to it.
My brain is hurting with this. Hang on, honestly, I'm just lost.
Well, first off, that should be number 16.
That's
16. No, that should be more.
Well, then I guess it
So that would
doesn't.
be squared y plus 2 squared.
Okay, so what are you rotating it around?
X is 2.
Okay, well, if all of your area is next to the line you're rotating it around, it's not gonna be washer, it's just gonna be this.
Because how am I supposed to find the area of this, these two?
Yeah, go ahead and erase those, get that out there. Okay, draw a couple of the circles, if you rotated that forward a couple of circles. Okay, there you go. So, you see how it's trying to get to these values?
Yeah.
Okay, so the way I did that is, and again, this is kind of what you should be building up to. But I saw that this was, this length, when y is 0, is 2. So this length, when y is 4, would be 0, the radius is 0. So the only way to describe that radius consistently is to say it's 2 minus whatever the square root of y is. But again, that's one of the harder questions, and that's why it's at the end. So the one before that, if you had that as, let me at least help you figure out which one you missed. Very number 5.
Wait, that's the last one.
You did that one correctly, but I have that as question 50.
I know, so he said this one, so I thought that was this one.
I have that as number 14, but you did it correctly.
Wait, this should be the last one.
Okay, you probably got one wrong, so where's number 3?
Unless we're wrong.
Okay, you did it correctly, but that's number 13. This is good. This is good because you're done some of the harder ones, so because they build up. Number 2.
This has to be number 2. There's no way it can't be number 2.
That is number 2. So that's one you have a mistake on. And
Oh, wait.
I think it's right in
Yeah,
here.
so it's X.
This doesn't look the same as what I have. You need to think about your R again. It shouldn't be 4 pi, it should be a different even number pi. So I'm not gonna tell you what it is, but that's the one you need to fix.
Or you just come back and say that later.
Wait, so we have to go back.
Yeah, that's it.
That's not number 6 that we have to.
Exactly.
Why?
But,
Oh, you stupid.
So the bounds are 0 to 2 because it's the X.
Last 6.
Yeah, because it's X squared, right?
Dumb boy.
Okay, so let's look at the
How come is the area?
What is that?
That means that when you rotate it, there will be volume.
Like all of these are
What I'm saying is that the area when you rotate it,
5 is right. 5 is right though.
So it should be like 6.4.
Wait, so how,
Well, because
so you do 4 squared?
if you look at 5, that, I'm trying to backtrack and see. His 5 should be too thin.
Is 5 not perfect to the class? Wait, 4?
4 is.
Why?
We're not going to be here in class Friday either because we have a tournament in Oklahoma.
Okay.
For the soccer. We leave at 8 in the morning. So,
You'll miss the USUB mini quiz, but you can make that up.
yeah, that was Monday.
Any advisory for just a couple minutes. I don't know. I haven't decided fully what we'll be doing next class.
We'll watch a video over the weekend
Okay.
anyways.
I'll
Just wanna let you know.
probably introduce the next topic and we'll probably spend a bulk of class on that, and then I'll probably give a little more time on this before I expect it to be due.
Yes, sir. All right, thank you.
It's a little more homework than I was expecting, so.
Well, okay, so. Now we can backtrack. Here we go.
Try doing this one.
Got it, finally.
Finish, yeah, because apparently.
Number 2 is 6 pi, right? Finally, beat it out.
17.
Beat it out of a prison of my own design.
I don't know what I did wrong there, but that's your bound.
Y, so that is 0.
Y-axis or just x equals 0?
Remember I said you can do this in the calculator. Or make it, if you want to practice this, fine.
Actually, what was it? Then you got 240.
Yeah, that's 128 over 5. Yeah. That's it for everyone.
I got 32/3. So when you type that in, oh, okay. I had checked it out. 0 to 2.
But this is 18.
Okay, now when you type it in, it should give you the decimal.
There's another line that's
So
called
you have to do math enter to try to get the choose the fact
Like
that
this, then this.
one thing that might be a problem.
It has to be 2.
Sometimes it has a tiny bit of rounding error.
It would be 60Y, and then you plug in 4 on these 2.
Again, you can practice this if you want to, start taking it, but you don't have to do all of
Let's
it.
do the other one.
If it's a real simple one, like question 1,
Or
find grade, this is
no square.
more words out.
Check 4.
16 over 3.
Okay, y'all got something common that's holding that?
Can I ask, is this the
That is number 5. And that's all right.
Oh, so then it's square the whole thing.
Wait, so that's the square root of 2?
That's not my 8, that's number 15 for me. Okay, put the 15 there and you work out that part later. Let me see what you did.
Yeah, it all seems right.
Yeah.
Like we're just gonna confuse ourselves more if we risk not runs this.
This looks like percentage.
Because if this is right, then that means this is also right, because then this would be 17.
Is it 3
Where
squared?
that goes to.
Squared minus square root of 1 squared.
No.
Okay.
And then,
Because your error is gonna be from here to here. If you square the square root of y, this just
This one has to be.
Oh, never mind. You did that.
Like this has to make a 30, like this has to be 17, so this can be 8.
Yes, but also. Wait, I don't know if that's right.
It's just using
Because you have to do like.
So you need 1 over 2.
I don't think 4 is wrong either. We're just. Well, look at 3
But
maybe.
yeah, this should be number 15, so this should be a little bit on the harder end. And then if you should put this one. Go back to number 7 or whatever. Y'all found something else?
Oh.
I just.
Hey, we're early. Oh, wait.
You're just on time.